and gentlemen, I am recording this, by the way. I want to go over this so that you have it. This is the review technique right here. Okay. So, number 1 is I. Number 2 is H. Number 3 is G. Number 4 is F. Number 5 is E. Number 6 is D. Number 7 is C. 8 is B.
9 is A.
Thank you. Okay. So you will not have something like this exactly on your test. You won't have to do the vocabulary. But if you know all of these things, you can answer all the other questions. Okay, that's why I put it on here. All right, so remember you can use your vocabulary or your postulates and theorems or a combination of both. Remember you can also come after school today for tutoring because the test is not till tomorrow. Okay, number 10. No. CA would have to be congruent to CB for it to be a perpendicular bisector. There's no connection between C and A and C and B showing that they're congruent, so that's why we know it's no. I'm going to move it to the top, but I'm going to put the next one up here. Okay. 11 is no. CP, so I just put letters for C and D right there, just so we know what we're talking about. C to P is not congruent to P to D, therefore it can't be an angle bisector because they would have to be congruent. This is the perpendicular bisector theorem, number 10. This is the angle bisector theorem, number 11. Okay. All right. Okay, next, ladies and gentlemen, let's look at number 12. Please don't talk while I'm talking. This is really important. You should have this all written down. Number 12. Can't be an angle bisector. Okay. Number 12. AC and BC are the same length, but AB would definitely be the shorter one. I found out the unknown angle by taking 180 minus 75 minus 30. Do we see that here? Okay, found that that one was 75. Since these are both 75, that means the sides are congruent. Okay, so they are both the longest side, but AB is across from 30, and that would be the shortest side. 13, E is the smallest angle, D is the largest angle. E is across from the smallest side, D is across from the biggest side.
You said we just listed out. That's fine.
Yes. Just make sure you always list it in order from least to greatest. 14, CAB are the angles. AB, BC, AC are the sides. For B, the angles are DEF, lengths FE, DF, DE. You'll have one just like this for your test. Any questions so far? We know the smallest angles across from the smallest side across from the smallest angle. We're good there? Okay, let's do that third angle theorem again. 9 plus 25, so I took the two things, added them together, made it bigger than x. I took x plus 9 is greater than 25 and found 16. I've had a couple of people ask me, why don't we do x plus 25 is greater than 9? You'd end up with a negative number, and you can't have a negative length for a side, right? Okay, 11 plus 10 is greater than x, and 10 plus x is greater than 11, and you'll get these inequalities, these compound inequalities at the bottom. X is greater than 1 but less than 21, and x is greater than 16 but less than 34. Okay. All right, 16. Okay. We know that RK, KS, and RT are all congruent to each other because it's a perpendicular bisector, and the distance from the circumcenter, which is the very center, to the vertices, the points of the triangle, are congruent. We also know that a bisector cuts all the sides in half. So we know RM is congruent to MS, SP is congruent to PT, Tn is congruent to Nr. You should be writing these down. Derek, I don't know what you're doing right now, but you should be writing these down. Write this down, please. You can eat chips and write at the same time. If you can't, stop eating chips.
I am.
Okay. So this is where it gets a little tricky. We have to use some Pythagorean theorem in here. We know that, we're agreed, right, that all those green lines are the same. Okay. We know that this whole length here is 32. Well, what's half of 32? 16. So both of these are 16. So if I'm looking at this triangle right here, I know, and I'm going to bring it out here, what it looks like. 12 by 16, and I've got to find x. X is what of the triangle? Is it A, B, or C for Pythagorean theorem? We know the hypotenuse is always C. You guys are worrying me. Hypotenuse is always the C value, and x is the hypotenuse because it's across from the what angle? The right angle, correct. So I do 12 squared plus 16 squared equals x squared. 144 plus 256 equals x squared. So 400 equals x squared. And how do I find out what x is? I square root it. Any questions about this problem? I think this is one of the most complicated so far. Yes, ma'am.
For the congruent one, is that RK is congruent to KN that is congruent to KC?
Yes. Yes. Questions about how I did the Pythagorean theorem and why? No? We're good? Okay. Let's look at angle bisectors. What do we know about angle bisectors? The distance from the center to where is all congruent? Sides. So see how they're all in green? Those are all congruent to each other. BW, WC, and AW are all congruent. What is the hypotenuse if I'm drawing a triangle? If I take this right triangle right here, 8, 10, or x, which one's the hypotenuse? 10, because it's across from the 90-degree angle, and it's also written on the paper. So I set up my Pythagorean theorem. A squared plus x squared equals 10 squared. Square them, subtract. X squared equals 36. Take your square root. 6 is WB. It doesn't matter which triangle you chose because all of the green ones are going to be the same, right? And we're looking for WB, which happens to be right here. Do I know any information about that triangle? No. But I know all the kinds of information about this one down here. And I know that all the green ones are the same. So I would look for the triangle where you have 2 out of 3 things. Okay. That's a good question. 18. It is a right triangle. This is why. What do we know about altitudes? Altitudes must be perpendicular and they must go through the vertices. It's the definition of an altitude. The only one that is perpendicular and goes through the vertices, let's look. Let's say this is an equilateral triangle. All the sides are the same. None of the altitudes are the whole side. Look, this is isosceles. These 2 sides are the same. Doesn't go through. This is an acute triangle. None of the sides are the same. Doesn't work. It only works for a right triangle. Where it's 90-degree angle. You should really write this down for this test. And it goes through the vertices. Okay? All right. Let's look at 19. 19 is maybe where we had some trouble. So we plotted our points. And we found out D, we're going to use the midpoint formula. So we did x1, which is 0, plus x2, which is 4, over 2, and got 2. Then we did y1, which is 0, plus y2, which is 10, divided by 2. Do you see I just used A, B right up here? Plugged them in. So I got 2, 5 is D, the midpoint of AB. Okay? Length, I used the distance formula between C and D. I know C is 8, 2, and D is 2, 5. So I did y2 minus y1 squared plus x2 minus x1 squared, and then found the square root of it. Okay. My suggestion to you for C is to find all the medians. Medians go through the midpoint to the opposite vertices. Okay? So we know that this centroid is where all three meet. Right here, this is F is the midpoint of AC. Is F. The midpoint of CB is E, which is 6, 6. Connected them, found that it was at 4, 4. All right, now I'm looking at D. D, I had to write down what E was, which is the midpoint of CB, 6, 6. And then I had to show that the lengths divided to 2/3. Well, I found the length of A to G, so I used the distance formula again. Length from A to E, distance formula again, we got 2/3. Okay, and then we're going to do our proof. Okay. 21, our proof. We've got the given. BM is congruent to MC, and AB is congruent to AC by definition of perpendicular bisectors. We know that AM is congruent to AM by reflexive, and the triangles are congruent by side, side, side. Yes, Anissa?
Why wouldn't you have to prove that M is the midpoint?
Why would you?
Well, you said...
Because what's the definition of a perpendicular bisector? It's a 90-degree angle that goes through, it's a line that goes through a side at its midpoint at a 90-degree angle. Since you know that, you don't have to prove that it's the midpoint. Thank you. We ready for 22?
No.
Okay. Mr. Van Hersen, while they're writing this down, would you pass these out? Make sure they have one angle bisector sheet and one perpendicular bisector sheet. Is there any other questions? There's different ways to solve this proof. I think this is the quickest way. Yes? I'm sorry, what? Why does it give you the point P to mess you up? All right. Going to move on to 22. Okay, 22, D, we had to find the midpoint. 5, 2, E, we had to find E as the midpoint of AB, which is 0, 3. Do you see how they look different? These are mid-segments. What do you think ED is going to be parallel to? AC. How do we know if they're parallel? They'll have the same what? Slope. They both have a slope of -1/5. We found the slope from E to D and the slope from A to C. Okay, now we've got to find the distances from ED and AC. And we got 5.09 and 10.19. ED is half as long as AC. Questions? No, they're not. No, they're not. No, they're not. Yes, those are the answers. Yep. Yep. Okay. So, ladies and gentlemen, you guys know your reviews were stapled around. On the backs of these reviews is all about, like, how to do perpendicular bisectors, and it's kind of the answer to what we're going to go through. I want to do one problem from each sheet together, and then I'm going to let you do the rest on your own. Okay, so Mr. Van Horsen is passing you out your sheets. We're going to go to circumscribe this triangle. Okay, so, thank you. I messed up that word 3 times last hour. Okay, circumscribe the triangle. All right, so you're going to take your compass. There's compasses in your box. So you're going to get a compass out of your box. It's very important to have a compass. Can't do it without it.